Again, nerds, we're on multiplying radicals. So you can put that at the top of your notes, and let's get math in. The product property of radicals says that if you have two pieces multiplied under a radical, you can break them up. Here's an example. A square root of 100, last time I checked, is 10. Well, plus or minus 10. There's always somebody that's like, Mr. J, it's plus or minus 10. Yes, 10. Because 10 squared, 10 times 10 gives you 100, so square root of 100 should give you 10. If you thought about 100 not as 100, but as 4 times 25, I picked this specifically, 4 times 25, 25, 50, 75, 100. This still is 100, but I broke it up with multiplication. And if we took the square root of this and the square root of that, square root of 4 is 2, square root of 25 is 5. Hey, look, you still get 10. This process works. And so it's this product property of radicals that we are going to use to solve some problems along the way. So I want to multiply these and write them in simplest form. Let's just jump into this one. This is 2 times root 5. Squared means you have 2 times root 5 times itself. So 2 times root 5 times 2 times root 5. Multiplication can happen in any order, right? 2 times 3 times 4 is the same as 4 times 2 times 3. So let's rearrange them and just call this 2 times 2 times root 5 times root 5. Right? This really is 2 squared, and this is root 5 squared, which is just 5, right? Because root 5 times root 5 is root 25. So you're working it backwards, right? If you could think about this as root 5 times 5 in the radical, like that. And then you could call it root 25. And that's just 5. So we usually take the shortcut and say, oh, hey, this square root and this square cancel each other out, and you just left with the 5 inside. But this is really what's happening. And this is 4. Right? Now, you can see how I'm like, it's annoying because I'm drawing with my finger, but I'm putting all of these in a nice line, right? Everybody can see what I'm doing. This is how mathematics is done. It's not my way. It's just how mathematics is done. If we played this game, you could do the same thing and call this root 3y, or let's call it root 3 times root y. Let's break it apart. Times root 12 times root y. Right? You could put the root 3 and the root 12 together and get root 36. That's nice because it's a perfect square. And you could also get root y times root y, which is root y squared. So this becomes, root 36 is 6 plus or minus. Yeah. And also y. Neat. Okay, so try some of these. The only difference is that I have 2 sets of these. So you need to distribute this in. Kaboom, kaboom. You end up with something that looks like this. So you get 2 sets of 2, 4, and you get 2 sets of root 3, 2 root 3. Play the same game here, but distribute the root in. And when you do that, you get 2 times root 5 when this distributes in. And this becomes root 2 times 2 times root 2, and the root 2's get together. Let's see if it shows us that. Let's slow that down just a touch. So this is root 2. This is 5 root 2 at the beginning. I hope that part's okay. And this is minus. Here's this 2. Here's this root 2. And here's this root 2 being multiplied in at the end. Some of you will do it like that in your head. Some of you want to lay it out. It doesn't matter, just as long as you're confident in what's happening. This is 5 root 2. And this is minus, this is 4, right? You can either put them together and go root 2 times 2, or you can just know that multiplying 2 roots together will cancel out that radical. So this is 2 times 2 more, right? So this becomes 4. Cool. Why am I asking you? You're not there. Yeah. Try reading my mind now, humans. All right, let's try these. Try these on your own and pause me until you got them. Go. Oh. Well, I wonder if you can still hear me. Can you still hear me? It looks like it. I just look like I'm pantomiming it. All right, I'm out. Tell me if I come back. All right, so here we go. I don't know what happened. If we multiply this in, we drop that in, ba-boom, ba-boom, we shouldn't be super surprised that we'll get negative 2 root 3. And then the root 3's will come together and give us this positive 3. Hope that's okay. And then this same thing here, when we multiply these in, this will give us a negative 4, and this will give us a positive root 6. I don't think we can peel that out of the denominator. Right, if you want to slow that down, this root 2 times root 2 is this piece. I don't really love how bulky they have that written out, but this is negative times a positive, so it's negative there, and the root 2 times root 2 becomes root 4, and the square root of root 4, the square root of 4 is 2. Right? These, the negatives, become a positive, and root 2 and root 3 multiplied, you'd put them both under a radical and go root 2 times 3, and that's 6. Okay. All right, now the fun begins. I think you've done this foiling, and so when we multiply binomials, we go first, we multiply everything by everything else, right? So that 2 times 3 starts you off with, oh, what an ugly piece of work. The 2 and the 3 give you the 6. The 2 and the root 2 give you this. The root 2 and the 3 give you that. And the root 2 and the root 2 give you a positive 2, right? And then we can just put the regular numbers together and the obnoxious radicals together. And you end up with this. Boom. Ew. Oh, that's our next one. Is 8 and then 5 root 2's. 2 root 2's here, 3 more over there. Did I come back yet? Nope. I'm always smiling. All right, let's play the same game with this one. Let's see. So, let's do this. When we multiply these in, this 3 and the 1 give you this. The 3 and the negative root 5 give you negative 3 root 5. Careful of your signs. The root 5 and the 1 are both positive. They give you that. And then root 5, negative root 5 gives you a negative result, but root 5s cancel out. You get 5. Shazangle, simplify. I have negative 3 root 5s, and I add 1, so now I'm at negative 2 root 5s. I had 3, I had to give away 5, so I'm at negative 2. Is that the last one? Oh, 2 more. Okay, here we go. To square this, do not drop this in and go ba-boom, ba-boom. Here's why. 2 plus 3, right, squared. 2 plus 3 is 5, and 5 squared is 25. So that should be 25. If you go squared, squared, and go 2 squared plus 3 squared, this is 4, this is 9, and that's 13. It's totally not 25. That doesn't work. You can't just drop in the squared. Don't try it. But what you could do, squared means multiplied by itself. So, I don't like that they did that. I'd rather, so what you can do is call this root 2 plus 3 times its dang self. And now you can play that FOIL trick we've been playing before. So root 2 times root 2 should give you a positive 2, right? Just a 2. Root 2 times 3 gives you 3 root 2's. Look at that. We get another set of 3 root 2's from there. And then we get 9 from there. Right? So you get 11 regular numbers and 6 root 2's. Play the same game with this one. Make sure you can get 8 minus 2 root 15's. Ugh, 2 root 15's. That's horrible. You'll be fine. All right. Last one with some negatives and positives. Are you sure? Positive. Just be careful with how things cancel out. So when we do that, we should get, ew, I don't want to see it. You get 4 squared. Let's call it just 16. No sense adding more squares and stuff. This is negative 4 root 2's. And this is positive 4 root 2's. And those are going to cancel out. It's like I took away 4 of your root 2's. No, my root 2's. And then I gave you 4 back. Oh, thanks. You've lost no root 2's. There's been no change anyway. So that'll cancel out to 0. And this is positive times a negative, so it'll be negative. Root 2 times root 2, just going to give you 2. Hopefully you can see that these will cancel out to 0. And you'll just be left with 16 minus 2, which last time I checked is a 14. Oh, thank you very much. Oh, thank you very much. Am I still there? Ta-da! Oh, hey, look! I look different. That's more what I look like, perplexed and confused. I hope this is recording. All right, and the last one, you're going to do the same thing. It's going to get a little ugly, but let's see. This, the 2 and the 2 will give you 4. And the root 2 and the root 2 will give you root 4, which is 2. So this gives you 4 when you multiply it, and this gives you a 2. So 2 times 4 is 8. So that's where they get this 8 in front. I don't like the way they write sometimes. So this gives us an 8. Okay. Let's multiply the next piece. I'll do it in a different color. So this is like saying 2 times root 2 times negative 3. Put the real number, and the whole number and the whole number together. You get negative 6 root 2's. So minus 6 root 2's. And then play the same game with this. That you should get, you get positive 6 root 2's, because 3 times 2 times root 2 is positive 6 root 2's. And then that gives you negative 9. These cancel out. Not the 8. Not the 9 either. And I think you're just left with a negative 1. Oh, thank you very much. Oh, thank you very much. Cool. I hope that was followable. I hope my face doesn't freeze like, hey, look, I'm back. Hi. Oh, my gosh. I hope that was followable, and I will catch you next time. What I'd like you to work on is 5E, work through those problems, and I'll see you later, probably. Okay, bye.